Insertion Sort scans through the list from left to right, and for each element it decides how far to shift it to the left. And it keeps shifting it to the left as long as the left neighbor is too big, because you want the left neighbor to be smaller than it. So we always start with the second element, because the first element is already shifted as far to the left as it can go. And so for this element we ask, do we need to shift it to the left? Well, we do if its left neighbor is too big, but it's not. In this case, 57 comes before 68, so we're actually done with 68. And then we move on to this one and we ask, do we need to shift it to the left? Is its left neighbor too big? And again, the answer is no, so we can move on. 37, do we need to shift it to the left? Is its left neighbor too big? Yes, it is too big, so we finally have to do a little shifting. And then we have to ask again, do I need to shift it to the left again? Is the left neighbor too big again? And yes, it is, we do. And again, the left neighbor is too big for 37, so we have to shift it to the left. And now that we're done with that one, we can see we're starting to build up a larger and larger subsection of this array that's sorted relative to each other. So all these green numbers are in order relative to each other, and so we have to then look at the next element we haven't considered, which is 26. Does 26 need to be shifted? Is its left neighbor too big? Yes, it is too big. We gotta go. Is 26's left neighbor too big? Yes, it is. Is 26's left neighbor too big? Yes, it is. Neighbor too big? Yes, it is. And then we move on to 49. Is 49's left neighbor too big? Yes, it is. Is 68 too big? Yes, it is. Is 57 too big? Yes. 37 is not too big, so 49 can just stop right there. And we move on to 59. Is its left neighbor too big? Is its left neighbor too big? Is its left neighbor too big? No, 57 is smaller than 59, so we're done with that. And again, this green region is growing and growing. And we do the same thing with each element, shifting it only enough so that its left neighbor isn't too big for it. That's good for you, 57. And that's good for you, 56. And you've locked into place, and now on to 7. 7 is a long way to go. And then we're up to 10. 10 also has quite a ways to go. It won't have to go all the way though, because once it gets up to 7, its left neighbor won't be too big. 7 isn't too big for 10. And 10 can just stop there. And then 93, he's got nowhere to go. His left neighbor isn't too big. He's already in place. 26 has to keep going until he finds his 26 doppelganger. And he's good. 24, almost the whole way he's got to go. Shifting, shifting, shifting. And finally, 64. How far does it need to go? Not too far, still a little more. Finally, your left neighbor is not too big, and so you are ready in place, and the array is sorted.